Hello everyone, my name is Hubert and welcome to Teach Me channel. Today we'll be looking at GCSE Physics current and circuit symbols. Now, this is an important topic because a big part of GCSE Physics will be all the electricity stuff. So this will give you a nice basis to sort of get into the whole electricity side of physics. So today we'll cover a bit about the three main parameters, the three main units that you need to understand: charge, current, and potential difference. And I will also show you all these different circuit symbols that you need to know. So without further ado, let's get started. First of all, here we have a circuit. We have a cell with this end being positive. We have a resistor, and we have a circuit flowing. Now, circuit always flows from the positive side of the cell to negative side of the cell. So that's how you know which way the charge in the circuit will flow. Now, charge is essentially the electrons that flow within that circuit, because electricity is all about movement of electrons, and that's what charge represents. The charge represents that sort of overall electrons. And then we have current, which is the rate of the flow of charge, and we have potential difference, which gives you the driving force that drives that current forward, that charge forwards. Now, I will explain this to you the simpler way. It's not exactly 100% correct, but it is the good way to think about these three different parameters. Okay? So, first of all, we have charge. We have Mr. Coulomb. We have a guy walking like this, and he's called Mr. Coulomb. I will explain to you why later. So we have Mr. Coulomb walking around. He's walking around the whole circuit, and what he does is he picks up a bag of sort of energy, and he walks with that bag all the way across the circuit, and then here he dumps whatever's left of that bag. So here he picks up a bag, and here he dumps whatever is left of that bag. Now, as he walks, he's using up that energy in the bag, right? So as he walks, he's using up that energy from the bag, and then at the end, he drops off less. He drops off less than he started with, because he used up the energy that's in the bag. So the difference between the bags could be called potential difference, which is how much energy got used up, what the change in the remaining driving force. So that's potential difference. I'm going to shorten it to PD. Now, Mr. Coulomb himself represents charge. He's the actual guy that walks around and does the work. So Mr. Coulomb represents charge. Now, the question is, how fast does he do it? So how often does he drop that? How often does he drop that bag off? The rate at which he drops that bag off is current. So the rate is current. And that's, maybe it's not 100% correct, but that's the good way to sort of get your head around what these different things actually mean. What current means, what charge means, and what potential difference means. Now, this makes sense, because current is a flow of charge. Current is the rate of the flow of charge. So, current is the rate. Mr. Coulomb's the charge, who is the guy that actually does the work. Charge is the actual sort of electrons that sort of push, that sort of make this whole circuit work, that flow across the circuit. And potential difference is the driving force that pushes that charge around the circuit, and it could also be described as Mr. Coulomb's bag and the difference between what he started with and what he ended with. Now, like I said, current is the rate of the flow of charge. Now, therefore, charge can be expressed like this: Q equals I T. So this is charge, this is current, and this is time throughout which the current was released. So that's the first equation you need to know, and that explains what charge is and what current is. So that's the basics. Also, charge is expressed in coulombs, which is C. It's a unit of charge. Current is expressed in amperes, which is a letter A. That's how we express current. And potential difference is expressed in, probably as you know, volts, which is a letter V. So those are the units to express these three different parameters. Okay, so enough on the parameters and on the basics of the circuitry. Let's move on to the different circuit symbols. Okay, so here we have the different symbols. Don't worry if it looks overwhelming, I will go over each one of them. So, first of all, we have cell. Cell is like a component of battery. Cell stores chemical energy that it will release as an electrical energy. So that's how we can think of a cell. Cell stores energy, chemical energy that it's going to be releasing as electrical energy to provide that potential difference to push the circuit, the charge forward. Okay. So going with that, battery is a group of cells that work together to provide enough power for whatever it needs to do. So battery is basically a group of cells. Now note that the wider bar represents the positive side of the cell or the battery, whereas the thinner bar represents the negative side. I will label it. There you go. So that's important to remember. Next one up, we have a switch. A switch is used in so many currents, so many circuits, because switch is a switch. It can turn the circuit on, it can turn the circuit off. So when the switch is open, we have broken the whole circuit, and therefore it will be off. Whatever, it's not going to do anything. Whereas if we close the switch like so, it's pretty self-explanatory. The circuit is completed and therefore it's gonna work. The device is turned on. Next up, we have a filament lamp. And in other words, it's a light bulb. That's it. That's just a light bulb that's gonna light up whenever the circuit is completed. This is a fuse. You may have heard of it. You may have heard or even dealt with a blown fuse. Which fuse is a device. It's a little device that's a safety measure. If the current gets too high, if the current flowing along the fuse gets too high, it's gonna break that fuse, which is gonna break up the entire circuit, and it's gonna switch it off. It's often used in plug sockets, for example. Every plug socket should have a fuse inside it. That keeps it safe to use and reduces the risk of fire immensely. Next up, we have a diode. Diode ensures the flow of circuit in a given direction. It only allows the current to go through, the charge to go through in one direction. It's used in more complex circuits, where sometimes electricity can start flowing the wrong way if you have many different loops. You sometimes may wish to use diode to steer the charge the correct way. Now, LED is a short for light emitting diode. So again, it's a diode that ensures flow of electricity in correct direction, but it also emits light. It's a little sort of bulb, essentially, that emits light. You can often see those in various electric devices. When you turn them on, that little light that flashes when it's on, that's essentially LED. That's a light emitting diode that indicates that the device is turned on, and it also ensures the correct direction of the flow of charge. Now, next one up is also, sorry, before I move on, also the arrow inside the diode indicates which direction it's supposed to be flowing in. So that's important. Now, ammeter is a device to measure current. And so essentially it's a circle with A inside. Easy to remember because A stands for amperes, which is the unit of current. And similar for voltmeter, which measures the potential difference, and it has essentially a circle with a V inside standing for volts. Now let's move on to resistors. So this is a basic resistor. You can buy resistors in various sizes that provide various resistances. By the way, the unit of resistance is ohms. We'll be doing more on that in further videos. Don't worry about this for now. But different resistors give you different resistances, and they're often used to spread out the power. So for example, in electric device, if you have a massive battery in your laptop and you need to run some very little process that doesn't require much energy, you use a resistor to stop loads of electricity flowing through something and just running out really quickly. So resistors are often used to sort of pace the device, if you will. So this is like a fixed resistor that has its own resistance, and it never changes depending on a size that you buy. That's the resistance it has. Variable resistor, on the other hand, you can manually sort of change it. You often twist the circle to change the resistance it provides. So that can be useful sometimes when you need to fiddle around. Sometimes it's useful for testing purposes when you fiddle around with the best resistance that you need for a device that you're trying to design. It has its uses. Next one up is a light dependent resistor, LDR. So it changes resistance dependent on light that hits it. And thermistor is very similar. It's a resistor that's dependent on temperature. When the temperature changes, the resistance it provides changes, which may sometimes be a safety measure to prevent overheatings and things like that. Okay, so this is it for today, guys. I hope this gave you a nice little overview of the basics of GCSE physics, electricity, all that electric stuff. Thank you very much for watching my video. I really appreciate when you guys watch these videos. If you have any questions, shoot me a question in comments. If you want to stay up to date on daily science, maths, and some biomedical science videos, hit that subscribe button below. If you liked the video, give me a big old thumbs up. Thank you again, and see you next time.